Every layer of the modern advanced industrial stack, from deep space ion thrusters to extreme ultraviolet lithography lasers, is entirely throttled by a single physical bottleneck: the scarcity of high-purity noble gases. Molecules like xenon, neon, and krypton comprise less than a fraction of a percent of the Earth's atmosphere, making their extraction an intensive exercise in extreme thermodynamics and atomic manipulation. In 2026, global venture capital funds and defense conglomerates have realized that holding digital intellectual property is meaningless if you lack the physical chemical inputs required to fire industrial lasers. Consequently, billions of dollars are flowing directly into plasma-kinetic extraction laboratories to secure absolute control over the world's rare gas supply chains. The foundational science of this resource scramble relies on advanced cryogenic fractional distillation coupled with plasma-kinetic ionization. To extract raw atmospheric gases, air must first be compressed to extreme pressures and cooled down to below -200 degrees Celsius, transitioning the gas into a hyperdense liquid state. Because every elemental gas possesses a highly specific, immutable boiling point, engineers slowly raise the temperature inside massive distillation columns, allowing individual elements to boil off and separate based on their distinct molecular weights. However, achieving the ultra-high purity levels required for modern industrial lasers demands a secondary stage of plasma-kinetic refinement, where the gas is subjected to a high-frequency electromagnetic field, ionizing the atoms into a glowing plasma state to instantly separate trace carbon or nitrogen contaminants based on their precise charge-to-mass ratios. The direct financial utility of this atomic engineering is the creation of a structural macroeconomic monopoly. Because these rare gases are completely non-reproducible by synthetic chemical means, the sovereign entity or corporate cartel that owns the physical distillation infrastructure dictates the manufacturing velocity of the entire global aerospace and laser sector. For institutional capital managers, holding physical reserves of high-purity xenon gas functions as the ultimate hedge against market volatility, as the element itself is a critical, irreplaceable industrial input whose physical value is backed by the absolute laws of atomic physics rather than arbitrary fiat decree. However, storing and transporting these ultra-pure noble gases introduces massive mechanical and materials engineering constraints. Xenon and krypton possess heavy atomic weights and can easily diffuse through standard industrial rubber or low-grade plastic seals, causing catastrophic purity degradation over long transit timelines. To prevent this atomic bleeding, logistics firms utilize high-pressure cylinders forged from high-tensile chrome moly steel or carbon fiber composites, lined internally with an atomically passive passivation layer of passivated aluminum oxide. Every single pressure valve must utilize a specialized metal-to-metal diaphragm seal engineered from high-purity nickel alloys, completely eliminating the presence of elastomers that could outgas and introduce microscopic trace impurities into the isolated chemical matrix. This convergence of plasma kinetics and rare gas asset allocation represents a permanent shift in how global industrial leverage is calculated. Capital is moving past speculative software platforms and locking itself directly to the primary elements of the periodic table. The institutions currently financing the construction of high-capacity plasma-kinetic distillation plants are establishing a permanent gatekeeper position over the physical execution of advanced high-tech manufacturing. The survival of elite industrial portfolios now depends entirely on mastering the thermodynamic phase boundaries of the atmosphere, proving that the ultimate guarantor of economic authority remains rooted in the absolute laws of plasma physics and molecular engineering.